Good morning viewers. Today we will discuss about the number system. First we will discuss about natural numbers, then whole numbers, integers, and then finally real number systems. So let's start with natural numbers. What are the natural numbers? The counting numbers 1, 2, 3, 4, etc. are called natural numbers. They are called counting numbers because we use them to count things around us. The history of natural number is very old. It is believed that they came into existence naturally. In ancient times, people used to keep sticks or pebbles with them to count things around us. Say, for example, they have domesticated animals, they would keep as many sticks with them as they have the number of animals. Later on, they started using clay symbols, or they started using markings on stones, and eventually these symbols turned into natural numbers what we are using today. So we exactly do not know who conceived the idea of writing 1 as this, 2 as this, or 3 as this, etc. That is why a German mathematician Leopold Kronecker said, God created the natural numbers and all the rest is the work of man. So it is believed that natural numbers are creation of God. Next we come to the whole numbers. The natural numbers together with 0 are called whole numbers. 0, 1, 2, 3, 4, etc. are called whole numbers. That means natural numbers and then 0. This combination 0 along with natural numbers are called whole numbers. Why they are called whole numbers? They mean whole of the things one by one, incomplete, and not a part or fraction. Say for example, there are 3 baskets. First basket do not contain any fruit. Say for example, in the second basket there are 3 apples, and the third basket, suppose there are 2 apples and a fraction of the third apple. So we see the first box contains no apples, that means it contains 0 apples. Second box contains, we will count it 1, 2, 3, 3 apples. And third box, it contains 1, 2, but we cannot count it as single number. It's a fraction of 1 apple, so it is 2.5 apples. 2.5 apples. So what we mean natural numbers? Natural whole numbers, they can be counted in multiples of 1. See this figure, we can count it as a multiples of 1. 3 apples means 3 times of 1 apple, but you cannot count it as a multiples of 1 because it contains 2 whole apples and half of the third apple. So it is not a whole number, it's a fraction. First basket, it contains no apples, means 0 apples. So that is why they are called whole numbers. We can count in multiples of 1, or it might we can count it in multiples of 1, or it might be 0, not in fraction. That is why they are called whole numbers. Now whole numbers, every whole numbers have a predecessor. Is it correct? No. 0, for example, 0 is a whole number, it doesn't have predecessor. It doesn't have a predecessor. But except 0, all whole numbers have a predecessor. For example, predecessor of 1 is 0, predecessor of 2 is 1, 3 is 2, 4 is 3. Similarly, every whole numbers have a successor. For example, 0 has a successor 1, 1 has a successor 3, 2 has a successor 3, 3 has a successor 4, and so on. So every whole number has a successor. Now what is the largest whole number? Does the largest whole number exist? We cannot find a largest whole number because every whole number has a successor. So if you are given a whole number, say 10 lakh, then I will find another whole number by adding 10 lakh 1. So you cannot find the largest whole number because every whole number has a successor. Now let's how to add whole numbers or subtract whole numbers on the number line. Whole numbers can be represented on a line, straight line. Say for example, this is we represent the whole numbers like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now suppose you are given to find out what is 4 plus 4. Now what is 4? In the number line we will count it from starting from 0. Whole numbers are starting from 0 and they are equally spaced. So when we mean 4, that means it is the distance from 0 to 4. This is 4. Then again plus 5, add 5. From 4 you count 5 one by one. Say for example 1, 2, 3, 4, 5. That means 4 plus 5 means we finally arrived at 9. So 4 plus 5 is 9. Similarly, say for example, take another example. What is 2 plus 3 plus 4? Now you represent the whole numbers on this number line. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Now 2, when we mean 2, you count from 0. This is 2 plus 3. 3 means from 2 again you count 3 one by one. 1, 2, 3. So 2 plus 3 means you arrived at 5. Then plus 4 again. From 5 again you count 4. 1, 2, 3, 4. So you finally arrived at 9. So 2 plus 3 plus 4 equals to 9. Now we try to subtract numbers on whole numbers on number line. Let's say another example. This is number line. Whole numbers we are trying to represent here at equally spaced 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Now say you are given to find 7 minus 5. What is 7 minus 5? So what is 7? From 0 to 7 you connect. This is 7. Now 7 minus 5. Minus 5 means you go forward or go backward. Minus 5. You go backward counting from 7. 1, 2, 3, 4, 5. So you finally arrived at 2. 7 minus 5 equal to 2. Take another example. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Now suppose you are to find 8 minus 3. Now what is 8? Counting from 0 you find 8 is here. This is 8. 8 minus 3. Minus 3 means you count backward now. From 8 you count backward. 1, 2, 3. 1, 2, 3. That means you arrived at 5. 8 minus 3 equal to 5. So how will you count whole numbers on the number line? Just you imagine this centimeter scale and you compare this with number line. So if you have to find 10 minus 5, how will you do it in this centimeter scale? 10 minus 5. 10 minus 5. You put the tip of the finger at 10. Minus 5 means you count backward. From here, from 10 you count 5 backward. 1, 2, 3, 4, 5. So 10 minus 5 equal to 5. Then 15 minus 11, suppose. You put the tip of the finger at 15. Starting from 0 to 15, this is 15. Now from 15 you count 11 backward, one by one. From 15 you put your tip of the finger at 15. Now count backward, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you arrived at 4. So 15 minus 11 equal to 4. So you have to find 8 plus 4. You put the tip of the finger at 8, or tip of the pencil at 8. 8 plus 4, 8. From 8 you count 4 steps forward, since it is addition. From 8, 1, 2, 3, 4. So you arrived at 12. 8 plus 4 equal to 12. This is how you can find addition or subtraction of whole numbers. Now we will try to find multiplication of whole numbers on the number line. Multiplication of whole numbers on the number line. Again you draw the number line starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Now you have to find, suppose 2 multiplied by 3. Now what is 2 here? In the number line, 2 means this distance, 0 to 2. Now you have to find 3 times of this distance, 3 times of this. 2 multiplied by 3 means you have to find 3 times of this. So 3 times of this is first one time, then second time, then third time. You are counting 2 steps in every time, because 2 multiplied by 3. So first 2 steps, 0 to 2. Second step, 2 to 4. Third steps, 4 to 6. So 2 3s are 6. Similarly, say you have to find 3 3s. Now you represent the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, etc. So now you see 3 means from 0 to 3. Now 3 times of this distance. You count 3 times of this. First you count one step, 0 to 3, one step. Second, 3 to 6. Third, 3 to 6 to 9. You are counting 3 by 3. 3 times. So first 0 to 3 one time. Second 1, 2, 3. Second step 1, 2, 3. Third step. So 3 3s are 9. This is how you can find the multiplication of whole numbers on the number line. You can use the centimeter scale to find it out. 3 means from 0 to 3. So 3 3s are 3 times of this. This is one time, 0 to 3 one time. Second time is 1, 2, 3. You arrived at 6. Again you count 3. 1, 2, 3. So 3 3s are 9. Similarly 4 3s are 12. 4 3s are 12. 4 means 0 to 4. 1 2 3 4. So counting by 4, you have to find 3 times of 4. Counting by 4, first 0 1 2 3 4, again 1 2 3 4, second step, then third step 1 2 3 4. So you arrived at 12. 4 3s are 12. This is how you can find the multiplication of whole numbers on the number line. Next step, we will discuss some more properties of whole numbers. Multiples and factors. Multiples and factors. Say for example, 2 is a whole number. Now you multiply 2 by 1. 2 1s are 2. 2 2s are 4. 2 3s are 6. Now these 2 4 6, these are called multiples of 2. You are multiplying 2 by whole numbers again. So when a and b are whole numbers, and if a into b equal to c, then we call a and b are called factors of c, and c is called multiples of a and b. Similarly, 5 6 are 30. Now 30 is called multiple of 5 and 6, and inversely 5 and 6 are called factors of 30. Similarly, say for example 4 into 5 into 2. 4 5s are 20, 2s are 40. So 40 is called multiple of 4 5 and 2, and 4 5 and 2 are called factors of 40. So say for example you have to find all the factors of 120. Now 1 into 120 equal to 120. We also find that 2 into 60 120, 3 into 40 120, 5 into 24 120, 6 into 20 120, 8 into 15 120. So factors of 120 are, what are the factors of 120? We find 1 2 3 5 6 8 15 20 24 40 60 120. These are called factors of 120. So 120 is multiples of all these numbers. So what we have realized that every number is a multiple of itself. 5 1s are 5. That means 5 is a multiple of 5. 20 1s are 20. 20 is a multiple of 20. 60 into 1 60. 60 is a multiple of 60, etc. That means every number is a multiple of itself. Similarly, 1 is a factor of every number. If you say 1, every number is divisible by 1. 1 is a factor of every number. For today, this much only. We will discuss more properties of whole numbers again. Bye bye.